CR Phase 6, Monitoring and Quantifying Direct and Indirect Emissions in Chapter 3. For installation operators, calculating CBAM emissions for additional information on calculating the specific total embedded emissions. Note: in the emissions data communication template, yellow fields indicate mandatory input from the installation operators. Light yellow fields indicate that input is optional. Green fields indicate automatically calculated results. In this fully filled communication template example, what are the main tabs to focus on? In tab B_Emonst, the required data has been entered, including the method of calculation, mass balance for this particular example, source stream name, for example, coke fines, iron ores, etc. Activity data, for example, amount of coke fines or iron ores used in the production process in tons. Carbon content, the amount of carbon found in the specific fuel and materials. In tab C_emission and energy, cell L25 displays the total direct emissions. The cell is automatically calculated once all required fields in tab B_Emonst are filled correctly. Cell M26 displays the total indirect emissions data. The installation operator needs to fill in this tab. See the section, Phase 6, Monitoring and Quantifying Direct and Indirect Emissions in Chapter 3. For installation operator, calculating CBAM emissions for additional information on calculating total indirect emissions. In tab Summary_Processes, all fields are automatically filled. The table automatically calculates the impact of heat and waste gas emissions on the total direct and indirect emissions. See the example 1, Integrated Steel Works and Conversion to Iron or Steel Products, on p.183 of the Guidance Document on CBAM Implementation for Installation Operators outside the EU, which you can access from the European Union's CBAM webpage for more information about this example. Phase 5, Monitoring and Quantifying Direct and Indirect Emissions. Once the installation operator has identified their specific total embedded emissions, they can move on to monitoring and quantifying their direct and indirect emissions. This should be done in 2 separate steps. Let's look into monitoring and quantifying direct emissions. Monitoring and quantifying direct emissions. There are several methods for monitoring and quantifying direct emissions. The installation operator should select the monitoring method that provides the most accurate and reliable result, except where a particular method is required for sector-specific reasons. Here is a brief introduction to these 3 methods for monitoring and quantifying direct emissions that are grouped in 2 approaches. 1. The calculation-based approach. 2. The measurement-based approach. Standard method. Mass balance method. Continuous emissions monitoring system. The calculation-based approach. The calculation-based approach focuses on calculating emissions from parameters such as the consumption of fuels and materials used in the manufacturing processes, the carbon contents of fuels and materials used in the manufacturing processes. Definition. Carbon content refers to the amount of carbon that is in 1 ton of material. Note: both default and actual values can be used in this calculation. Emissions calculated with actual values are more accurate than emission calculated with default values. See the Annex 8. Standard factors used in the monitoring of direct emissions at installation level of the implementation regulation for additional information on parameters. There are 2 different calculation-based methods. The standard method involves determining quantities of all the fuels and input materials consumed and multiplying those with calculation factors such as the net calorific value and emission factor. These calculation factors are typically determined either based on sampling and analysis or by the use of standard factors. Calculation formula. Quantities of all the fuels and input materials consumed x calculation factors equals result. The mass balance method involves determining the carbon quantities of all fuels, input materials, and output materials. This mass balance results in a difference between the amount of carbon entering and leaving the installation. This difference will be converted into CO2 equivalent emissions. Calculation formula. Input materials, output materials equals result dash to be converted into CO2 equivalent emissions. In which case is this method used? The mass balance method is typically relevant where carbon remains in the goods produced, for example, steel. The measurement-based approach. The measurement-based approach focuses on continuous measurements of emissions from emission sources at the installation level. These measurements provide direct data on the amount of greenhouse gases emitted. What are the techniques used to measure these emissions? Directly in the factory's chimney stacks. Using extractive procedures with a measurement instrument located close to the chimney stack. In which case is this approach used? CBAM requires the mandatory use of the measurement-based approach for monitoring of nitrous oxide, where this is defined as a relevant greenhouse gas emission for the CBAM good, for example, for nitric acid and fertilizer production. Let's look into monitoring and quantifying indirect emissions. Monitoring and quantifying indirect emissions. For monitoring and reporting indirect emissions, installation operators need to report the quantities of electricity consumed for each product imported and multiply it by the relevant emission factor of electricity. For the emission factor, in the case the electricity comes from the grid, the following methods could be used. The average emission factor for the country of origin's electricity grid, based on data from the International Energy Agency, IEA, provided by the commissions. Any other emissions factor for the electricity grid of the country of origin, based on publicly available data. Available data representing either the average emission factor or the CO2 emission factor as referred to in Section 4.3 of Annex 4 to Regulation, EU, 2023/956. Let's look into ensuring data quality according to the method used. Ensuring data quality. Installation operators should provide information on the type of method used for monitoring and quantifying direct emissions. They should mention whether it is calculation-based. Default and actual values were used in the calculation. Measurement-based, based on monitoring of emissions, meaning actual values were used in the calculation. This difference in calculation methods results in a difference in data quality. Indeed, emissions calculated with actual values are more accurate than emission calculated with default values. Phase 6. Calculating the specific total embedded emissions. Once installation operators have identified their direct and indirect emissions, they can calculate their specific total embedded emissions using specific production data. Definition. Specific embedded emissions are the embedded emissions of 1 ton of goods, expressed as tons of CO2 equivalent, emissions per ton of goods. To calculate the specific embedded emissions of a product, installation operators need the following information. The total greenhouse gas emissions from the goods production, which represents the sum of greenhouse gas emissions released during the production process in tons info 2e. It includes both direct and indirect emissions. For this, installation operators will need to add the total direct emissions of the production process for the identified product with the total indirect emissions of the installation. The total direct and indirect emissions have previously been calculated in Phase 4 of this chapter. The total good production volume, which refers to the total amount of goods produced within a specific time frame. It is usually measured in tons. The goods production process, including the type and efficiency of the technology used, and whether any emissions reduction measures are in place. Once installation operators have gathered this information, they need to divide the total greenhouse gas emissions from the goods production by the total good production. See the section for installation operators calculating CBAM emissions within the Chapter 5. Reviewing a scenario of this course for additional information on this calculation. Phase 7. Identifying the qualifying parameters. Qualifying parameters are the sector-specific parameters required to be reported by the installation operators. These parameters depend on the goods produced. For example, installation operators should mention precursors such as the total clinker content needs to be reported for cements imported. The contents of the different forms of nitrogen need to be reported for mixed fertilizers. The relevant qualifying parameters are listed in Section 2 of Annex 4 to the implementing regulation. Phase 8. Calculating the total emissions of the installation operator. Once the installation operator has monitored their own direct and indirect emissions, they can move to the last step of the CBAM calculation, which is calculating the total emissions. CBAM recognizes that different product categories may have varying degrees of emissions intensity. As a result, the mechanism allows for differentiation in the treatment of emissions based on the specific product category. For example, under the European Commission's Iron and Steel section, guidance is provided to help installation operators calculate specific embedded emissions. The e-learning course focuses partly on calculating the specific embedded emissions in the fertilizer sector and acts as an example of how this can be applied to a specific sector. See the European Commission's Sectoral Information section for additional e-learning courses and course takeaways on calculating the specific embedded emissions for all 6 CBAM transitional sectors. Fertilizer opens in a new tab. Cement, aluminium, iron and steel, hydrogen, and electricity. Note: these requirements are non-exhaustive. Installation operators might need to provide additional data according to the goods they are exporting to the EU. CP.169, 225 of the European Commission's guidance document on CBAM implementation for installation operators outside the EU. For additional information on the data required from the installation operators in order for them to fill in the emissions data communication template. This document provides additional examples on sector-specific calculation examples per sector, production process, route, precursor, calculation methodology, activity data, etc. See the For Installation Operators, Calculating CBAM Emissions section in the Chapter 5. Reviewing a scenario of this course for additional information about calculations. Phase 9. Sharing data to the reporting declarants. Once all the data from Phase 1 to 8 is collected, the installation operators then need to share the necessary embedded emissions data with reporting declarants. To do so, installation operators should make sure they have filled in the emissions data communication template, which they can then share with their reporting declarants. This allows the reporting declarants to calculate their final cost of CBAM and buy the required certificates. Note: to help installation operators share their data with their reporting declarants, EcoVadis offers the carbon product data feature. See the Reporting CBAM Data on the EcoVadis Platform section of the Chapter 6. For installation operators, disclosing product-level data with EcoVadis tools of this course for more information about this feature. To conclude, did you know? If the CBAM does not currently apply to installation operators' portfolio of goods, it might still apply to them in the future. The CBAM's current scope is only provisional. The EU Commission plans to gradually expand the scope of application to cover all industrial goods by 2034. What's next? Great job! Now that installation operators have learned about calculating their CBAM emissions, let's focus on calculating the cost related to buying CBAM certificates.